fighter, yeah. If you want me, put up your lighter, yeah.
Good evening, everybody. Thank you for joining us tonight. My name is Michelle December, and I'm the Learning Director here at the Aspen Art Museum. And I am especially excited to be introducing our first in the 10th anniversary series of the Architecture Lecture Series, which is graciously supported by the Question Education Fund. I personally have always had a kind of soft spot in my heart for our architecture lectures, being that I wanted to be an architect when I was a kid. And then I realized how much math was involved during an internship in high school and realized maybe I'll just respect it when it's finished. So we're really excited. We have a really great lineup this year that we're very excited to kick off with Paul Lewis. As you probably know, we have a tradition of having a local architect provide the introduction, so we'll be doing that shortly. A heads up about some of the other events that we're doing as part of our architecture lecture series. We'll be welcoming Todd Williams on February 8th. And then in April, which is Colorado Architecture Month, we have a couple of really exciting new, more experimental events that we've been cooking up with the help of some of our local friends. If you have ideas or if you want to get involved, please reach out to me. We'll be hosting a sort of Pecha Kucha event in April that more details will be coming, really focused at emerging architects in our valley. So stay tuned. Reach out if you're interested. Come say hi to me at the end of the event. And I'd love to meet you and hear your ideas. So without further ado, I'd like to introduce to you somebody that many of you, I'm sure, probably already know, Scott Smith, who works at Charles Cundiff Architects. He is the senior project architect and the general manager. He also serves as a kind of outreach and getting a lot of us enthused as part of the American Institute of Architects. And that's how I came to know him, and I'm very honored that he's here to do the introduction for us tonight. So please join me in welcoming Scott.
Thanks, and thank everyone for coming. We have a very special guest tonight. Paul Lewis, FAIA, is a principal at Lewis.Tsurumaki.Lewis Architects based in New York City. He is currently a professor and associate dean at Princeton University School of Architecture, where he has taught since 2000. He received a Bachelor of Architecture from Wesleyan University and a Master of Architecture from Princeton University. LTL received a 2007 National Design Award and has received multiple AIA Design Awards. Their recent built work includes the Contemporary Austin, an art center in Austin, Texas, Steeplechase Pier at Coney Island, a new administrative campus for the Claremont University Consortium, and projects at Vassar College, Cornell University, New York University, and Columbia University. In 2017, they won an invited design competition for an art center in Telluride, Colorado, which is a really beautiful project if you want to see it on their website. And Poster House, a museum dedicated to posters located in New York City. Their newest book, entitled Manual of Section, an analysis of the history and typology of section in architecture, was released in 2016 and was selected by the German Architecture Museum as one of the 10 best architecture books of the year. Paul is a board member of the Architectural League of New York and a fellow of the American Academy in Rome. On behalf of the AIA Colorado West section and the Aspen Art Museum, we welcome Paul Lewis.
Thank you both for the introductions. It's a pleasure to be here. It's a pleasure to be part of the 10th anniversary of the Architecture Lecture Series. And I'm going to be talking about Manual of Section. And in part, we wrote this book coming out of our interest in section and also our frustration with the limited amount of scholarship, the limited amount of kind of analysis about section, despite its prominence within the discipline of architecture, within teaching. I can't tell you the number of times I've been on an architecture jury where the comment has been that a student doesn't have a good section, but there's no clarification as to what that actually means. And so we've been very interested in section both as a kind of drawing type, but also as a means to generate design. We've worked through section not as a kind of cut after the fact, but actually as a means to think about a project. And we find section to be a kind of fundamentally unique way of thinking about space. It's a way of thinking in a building about how things like the structural systems, the mechanical systems, the enclosure, thermal forces, how all of these come to play and have an influence on a project. What's fascinating about a section, which for those of you who don't know, it can be really described as a vertical cut through a building. But what it starts to reveal is things you can't necessarily see, and it's a way of understanding a building in a very kind of unique way. What's also fascinating is the section also organizes kind of social hierarchy. In some ways, the section, more than the plan, starts to show the relationship between the building's interior, its relationship to the street, its organization, say, between shops on the ground level versus penthouses on the upper level. It's a fascinating tool, and it tends to be underplayed. And in fact, often section is currently now used after the design is generated, which is unfortunate. And we encounter this both in other practices and also in teaching, where often a three-dimensional model is made and the section is then cut after that model's been produced as a way to understand the model as opposed to generate the design. And one of the fascinating things about section's history is that as a drawing type, it actually came out of that kind of logic. It was actually a drawing that was used to analyze things after they already existed. So the history of section and its current use have a kind of an affinity. So if we go back to some of the earliest section drawings, they were cuts through existing bodies, whether it was in Leonardo's drawings through the human skull, or the way in which architects would use sections to analyze monuments of antiquity. It was a way of understanding, by measuring the exterior profile and the interior profile, you could guess at the thickness of the wall. It was a way of analyzing, again, bodies that already existed. And so even in Palladio's kind of well-known pattern book of architecture, the section is seen really as subservient to the elevation, and in a sense the plan as the dominant representation. One could even argue that in terms of architectural drawings, the history of architecture is really kind of a history of plan and a history of elevation, and we in a sense would be interested in thinking about a history of architecture through the section. We also, as a drawing type, we really love the collaboration or the kind of affinity between a section cut and perspective. And the reason for that is that the section cut is this kind of perfect kind of vertical slice, this abstract slice that goes through things you can't see, that allows for dimensional accuracy, that allows a kind of precision, and yet the perspective kind of allows you to inhabit the project. So you get these two totally different representational techniques coexisting, the abstract and the embodied, and it's a fascinating kind of drawing technique that we use a lot in our own work, and we used as the basis for the drawing type that fills the book. Okay, so what do we do with the book? In the book, we argue that there are 7 dominant models by which architects make section. And it's not to say that there aren't other types of sections possible, but these are what we regard to be as the 7 distinct and most prevalent ways by which architects work in the vertical axis. That it's the way in which architects work and produce section effects, particularly on the insides of the building. The 8th one here is hybrid, which frankly is most buildings. Most architects work through a kind of collage or a combination of these different section types. So we wanted to kind of articulate what these are in order to provide a kind of basis for analysis, in order to provide a kind of point of departure for proposing new models of section through hybridization. The way we did this was to look at 63 buildings. We We drew specific cross-sectional perspectives through each of these. The book is essentially just those 63 drawings. We wanted to have just a single drawing per building. A lot of analysis of architecture gets reduced to a series of diagrams, and we were interested in the kind of wealth of things that occur within a building that can be best represented through a single drawing. But these are all section perspectives, all done with line work, in part we wanted to find a way that we could sell the book for about $20. And so it was all black and white drawings, so it could be printed cheaply and therefore sold and acquired, in particular by students. So, okay, so I'm going to use the 7 section types to organize the talk, both presenting the different section types and also then presenting some examples of work from our office where those section types were dominant. So extrusion is the simplest section type. In fact, if one looks at a building and says, oh, that section isn't very interesting, it's probably because it's just an extruded section. So in some ways, this is the most banal version of section, where all you're really doing is lifting the ceiling height up to the height necessary for a particular program to exist. There's not that much else going on. But there are possibilities within an extruded section of doing something interesting. So Philip Johnson, for example, in the glass house, worked in an incredibly kind of refined way to kind of float the ceiling above the floor, which puts a huge amount of emphasis on the glass that has this amazing reciprocity with the landscape. So it's an extruded section, but it then really celebrates the minimal nature of that extrusion. On the other hand, if this was extruded to just 10 foot, say 10'6", you can get much more interesting qualities if you extrude your space up to, say, I don't know, 83 feet, as Nervi did in the Palace of Labor. So you get this incredible spectacle because it goes beyond the kind of efficiency limits and starts to produce a space that's almost a kind of an exterior captured within this extremely high, structurally magnificent project. So the first project I'll present is a school. It's an early childhood education space for about 200 students in Arkansas as part of the Design Excellence Program in Arkansas. And we knew very early on that this was going to be basically a project that would be limited to an extruded floor plan. The site is flat or largely flat, and that the construction cost was quite restrictive, so we knew we'd be dealing with kind of bar joists. And we also knew that from a standpoint of utility for the young children, that steps were probably not going to be possible, so it was going to be a large single-story building. So what do we do within there to start to produce some variation? One thought was to say a lot of our work would be played out in plan, but that even within the kind of the kind of stretching of these double-loaded corridors of classrooms that would be gathered around a center space, we wanted to, internal to the classrooms, that there would be a kind of house within the room. So each classroom was designed as a house within the individual room, allowing for a kind of more acoustically separated area, an identity in the hallway, and also projecting out to the outside porch the identity of the students' own houses or the children's own houses. So in a sense, kind of placing within the extruded section a variation, a kind of a figure within that space. In plan, the individual classrooms of similarly aged students or children would be gathered around a separate pie-shaped playscape that would be designed to match their age. And here you see the way in which the framing of that house starts to mark the screen of the outside play space and then connect to the collective play area outside. There was an attempt to mark the extruded height around the perimeter of the site. So rather than just a standard 6-foot-high fence, these are 20-foot-high posts that form battens along the front of the building, but then kind of migrate out almost as if the detail starts to inhabit the front, presenting a kind of marking or a kind of gathering of the building in anticipation of itself, and starting to form this kind of collective gathering space at the front of the building. The heart of the building is the kind of gross motor rooms that become the point of departure. And one of the things we really liked is that although there be a center area, there's no distinct center within the plan. In other words, that if you just start to take the arcs and the kind of central axis of these corridors, they all miss each other. There's no single privilege point within the space. It's a series of collections of different centers, different kind of gathering areas. And the collective area here would be both 3 gross motor rooms, but also be capable of being opened up to allow for about 300 people to gather within this central community space. So a number of the restaurant projects we've done in New York City have been limited to extruded sections, and a lot of our pleasure then gets played out in materials. So a good example is Fluff Bakery, where once you lay out the plan as efficiently as possible, a lot of your interest then gets played out in the thickness of the skin of the interior. And so here we started to imagine how you could start to stack 3/4-inch thick felt and plywood to start to kind of line the entire interior of this space that would produce this kind of sense of velocity, a kind of movement when seen in perspective. But then when you look at it as an elevation, it starts to flatten the relationship between the wall and the ceiling. And this surface then would do many things. It would be the padding. It would be acoustically effective. It would have, it would shift from dark to light so that where it would get more wear, it would be a darker color, but it would then illuminate the space better by shifting to white up top. The felt also started to work as a kind of signage, right? So that people would walk down the sidewalk and kind of be captured by this, what we like to refer to as the moment of jumping into hyperspace, that kind of velocity image. Unfortunately, the food was not particularly good, and it was very expensive, and the place closed in a year, which is typical for New York City. But it was still a project we think back on quite fondly. Another very small restaurant that we did at this time was a hot dog stand. It was about maybe 200 square feet. It was, well, you can tell based on the toilet, right? The thing is tiny. And so the thought was to make the thing nothing but the act of getting a hot dog, so that you would line up on the sidewalk down here. You'd walk in the front door, you'd order the hot dog, you pay for it, you'd eat it on the counter, and then you'd leave. And the client imagined that the entire sidewalk would migrate into their hot dog stand. So what we did for this one in terms of the section was to actually argue that rather than keeping the space as high as possible, we do something counterintuitive. We'd actually raise the floor, and we've dropped the ceiling to give the illusion through a forced perspective that the space was actually bigger than it was. So here it is normal, and there's with the effect of the forced perspective. And we, in a sense, convinced the client that this was the right thing to do, because it would make their hot dogs seem bigger when they sold them. But from an architectural standpoint, one of the things we were very interested in is how that initial diagram would then be played out in terms of details. So the steel, the cold rolled steel that lines the floor and the ceiling went from 6-inch wide planks to 2-inch wide. The dotted line registers the difference between anticipation and consumption. And then the bamboo counter, which cantilevers from the street into the space, is level, where the floor is sloping, so it allows anybody or people of different heights to find a comfortable place to eat along the counter. Okay, so stack is the second model of section, and it basically argues that you can produce section by starting to kind of place floors on top of other floors. Not terribly complicated. It's a way of kind of producing a maximization of the real estate of your floor plate. And again, like extrusion, generally it doesn't produce that interesting effects in section. But when handled appropriately, it can be quite interesting. So one example is the Crown Hall, which is this magnificent extruded space by Mies van der Rohe in Chicago, is really dependent upon stacking on top of a more service-oriented space in the lower level. So here you have stacking not of self-similar floor plates, but actually different scale sections in order to allow that grand space to be as free as possible, to not have bathrooms, to not have all the utility, which is then carried in the lower level. And certainly that difference between service and served is something that Lou Kahn used a lot in, say, the Salk Institute. A different way to approach the stack section is to imagine displacing that stack section in space. So with Lino Bobardi's museum in Sao Paulo, the stack section is actually placed up above the ground plane, and that allows the city to migrate in underneath this kind of magnificent kind of floating volume. You see the kind of extraordinary concrete beams that actually span across the space that both kind of suspend and lift these stack sections above this kind of new grand public space below. Another way to look at variations within a stack section is to imagine that each floor plate is unique. Each ceiling height is different. And Rem Koolhaas's analysis of this building, this is the Downtown Athletic Club in New York, is a good example of that, where every single ceiling height is unique, often mapped to the particular sport that took place on that in the athletic club. So whether it would be squash here, or mini golf, or boxing, or swimming pool, each of the floor heights are unique. And you get this kind of very interesting quality in the building that's actually not seen from the outside, but only revealed through a section drawing. I happen to rent an apartment right here, which is the billiard and card playing floor. And one of the weird things about our apartment is you actually go up a ramp and there's a false floor that's 2 feet higher than it needs to be in order for us to look out the window, because the card playing and billiard floor was designed with windows high enough up that you wouldn't be distracted by looking out. To turn it into cookie cutter apartments, they had to actually put in this false floor, but it's great because that means my kids can jump up and down and our neighbors below don't complain at all. So there are certain advantages to anomalies within sections. So, MVRDV took this idea of difference within the stack section to an extreme degree in the Hanover Pavilion, where not only were there different ceiling heights, but there were different materials, there were different structural propositions, different ecosystems, a way of kind of stacking the different landscapes of Netherlands on top of themselves in this World Expo. So we were interested in the idea of kind of stacking as a way to deal with some of the kind of problems of the American suburb, as a way to kind of think about how McMansions and big box stores could be mated in section. In other words, could you maintain the American dream, but mitigate some of the problems of sprawl by allowing the residential communities to exist on top of big box stores. And for us, one of the interesting things about this diagram was that it was dependent upon the autonomy or the relative autonomy of these two pieces. That they would be infrastructurally connected. You would have the apartments or the houses above the big box stores, but effectively you wouldn't necessarily know it. You might get the efficiency of, say, green lawns, using the excess heat from the big box store to keep your lawn green all year round. But to get from the house to the big box store, you'd have to commute around the block, and that might open up the possibility of a parking lot becoming a kind of a stadium for a local sports team. So looking at ways that we can work through stack sections to produce new models of suburbia, which usually don't depend upon section at all. In a slightly more serious project, we were looking at some of the problems of these kind of neighborhoods in the Back Bay of New Jersey that were built on wetlands. They probably should have never been built there. From satellite views, they look a little bit like parasites or diseases, kind of extraordinary places. And in particular, we were looking at the Back Bay of Atlantic City, a community called Chelsea Heights. And the issue here is often the ways to deal with sea level rise and these very low-lying communities is to kind of set up a kind of false binary, that either you have to fortify with a seawall, which has all kinds of problems, or there's a kind of retreat model, which is also politically very difficult to encourage people to do, right? It effectively involves the removal of that neighborhood. So we are looking at a way that through working with a stacked section, through working in section in these kind of communities, you could actually produce an amphibious suburb. And so what this means specifically is that we would take on the ability to look at lifted houses, which are actually kind of extraordinary in their own right. you get these lands that are being sold now with the platforms already built on them as part of the infrastructure. And there's an incredible kind of new model of lifted houses, which raises very interesting questions of simple things like where's your front door in a house like this? So that it hasn't been dealt with, right? Is it really kind of the kind of sixth elevation from underneath that's now the front door? What does that mean? There are other kind of interesting cases where lawns are now being replaced by these surrogate decks, these huge decks that are expanding to make the area below even darker and more foreboding. But anyways, our interest was to say, given the fact that this is already happening, how can we capitalize on this? How can we look at a kind of a way of thinking the next 100 years of this neighborhood by the incremental lifting of houses, lifting of infrastructure, imagining that one could start to have permeable kind of a seawall. So right now, this neighborhood of Chelsea Heights was extremely flooded and sandy. Our argument is that one should build a kind of a porous berm that allows water to come in, that allows the wetlands to flood. Some of the redundant canal back alleys should be turned back into canals to allow the wetlands to migrate back. But this would produce some initial protection against the storm surges. But over time, and we're looking at 100 years here, is that one could imagine that the wetlands could come back, whereas the elevated houses, the elevated infrastructure, streets, sewers, et cetera, could then set up a model where one could embrace flooding as not being a problem, but just something that's perfectly acceptable and doesn't have catastrophic damages on the neighborhood. So following Sandy, we also got the opportunity to reimagine Coney Island Steeplechase Pier, which is this long pier extending out here. It's a kind of fantastic kind of site, if you will. It's 3 football fields long. It was basically heavily damaged as a result of Hurricane Sandy. And from a section standpoint, it's incredibly thin. So a lot of our work was spent in looking at very subtle ways to deal with the vertical access at the level of even seats. We invented kind of push you, pull me benches so that you could sit with somebody who wanted to people watch. If you wanted to look out towards the water, you could kind of sit together, but looking in opposite directions. Chaise lounges that allow you to collectively sunbathe. And then at the central joint of the pier, imagining a shade trellis that would then cast the letters of Coney Island onto the surface of the deck, kind of marking the identity on the surface through shadow. And then at the end of the pier, a slight variation to the surface level to allow people who are there just simply to view this, the horizon, look out to the water, to coexist with the fishermen who kind of fill the perimeter of the pier, and then also get that elevated position to then turn back and look at Coney Island beyond. Okay, so shape is the next model of section, and here the argument is rather than flat floors, one can start to modulate the contour either of the ceiling or of the floor, and often this is done to coordinate and organize groups of people. So a couple of good examples of shape, and shape often, particularly when it's used in the ceiling, is because there's a coordination between the structural forces and the kind of form of the ceiling. So in Candelia's thin shell concrete projects, not only does one get this incredibly beautiful kind of structural proposition, but it helps organize the restaurant into a series of smaller areas, or relatively smaller areas that then have links back out to the park beyond. A different use of shape in a church by Jorn Utzon is to use the cast concrete baffles as kind of cloud-like environments that then choreograph the relationship between the minister and the congregation, in a sense kind of bringing the heavens in through indirect light. So the shape here is all about kind of staging the relationship between the social dynamics of the people. In a very different way, Corbusier in Ronchamp kind of squeezes through a kind of through the kind of belly of the ceiling, squeezes the connection back out to the hilltop view and to the outdoor chapels that are gathered around the periphery of this building. It's a very different way of kind of gathering and linking people. What was fascinating about this section drawing is that everything that appears heavy within the building is actually super thin. So what appears to be this massive wall is actually just a thin line of gunite, whereas then the walls that actually appear to be thinnest are actually technically the thickest. So the kind of interesting inversions at play within this building. Now, one of the problems of shaped sections is that, particularly when they're used in floors, is often there's only a brief moment where they're horizontal. And so in Toyo Ito's Opera House, which is this magnificent proposition of a kind of an extremely contoured shaped section, you start to see the limits of what you can do. In other words, there's only a particular moment where it flattens out to be occupiable. So therefore, the shaped section diagram has to then be kind of mixed in with a kind of stack section in order to provide the space for the program that has to then fill up particularly the back of house areas of the opera house. Okay, so we've been interested in how you could work with simply contouring the ground and the ceiling in a project. This is a museum competition in Egypt, and the entire argument of our whole project was that we were going to simply critique the diagram of the traditional gallery that tends to kind of position a ceiling as distinct from the wall, and art on the wall, benches or sculptures in the middle, and you get this very kind of limited sequence of relationships. So we were kind of curious what would happen if you simply contour the ground and contour the ceiling. Could you set up a much more complex possibility of relationships between interior, exterior, between different programs, between different scales of gallery spaces, and we then based the entire project on that diagram and variations on that diagram. And we liked very much the possibility that you could get these alignments between, say, the photovoltaic ceiling and a kind of display wall, interiors mated to exteriors, moments where you would feel like you were underground, but you're actually much higher up in the air, through not seeing a conventional gallery aggregation, but a much more intriguing one. Now, we didn't win that competition. I think there were 1,000 entries, there were 1,500 entries, but we were able to kind of realize the basis of this diagram in an all-you-can-eat buffet in Las Vegas, which is where good ideas go to be tested out in slightly watered down or strangely American ways. And so this was a dining hall or a buffet for about 600 seats. And we wanted to find a way that we could both kind of contour the banquettes and contour the ceiling to produce smaller areas of dining that would make you not feel like you're in this cavernous cafe. But you would also, when you stood up, you would have a view to the serving stations and also to the garden and the pools outside. So it's slightly different than what we were trying to do in the museum competition, but still a similar argument about designing an entire project in section through the shaping of the floor and the shaping of the ceiling. We tend to spend more time drawing the reflected ceiling plans than the plans themselves. This is the reflected ceiling plan, which is really a kind of an untapped kind of site for experimentation. You can do so much in the ceiling because people aren't walking on it. And so that was something that we wanted to experiment. There's simply just that much more activity and dynamics within the ceiling. Okay, and another shaped section that we worked on in an existing building, it was a maintenance building in Claremont, at the Claremont University Consortium, and we were asked to rethink this as an open office for the administrative headquarters for the organization that serves all of the Claremont colleges. Here you see the kind of shot of the maintenance building and the kind of plan, the open office arrangement. And what was fascinating about this is that here we had the opportunity to work with just a single story building, but one that had 35-foot high almost column-free space. I mean, if we were to do a ground-up office building, we could never justify that scale of construction, right? So, but we also realized that almost all of our work was going to take place in the ceiling. The concrete was too hard to trench, so all of the kind of skylights, all the infrastructure, all of the mechanical system, electrical data was all going to run in the ceiling. So in effect, that became the heart of the project, and developing a kind of custom baffle system that can be draped like a marionette, that would then form a kind of cloud-like ceiling defining the entire project. But it was set up in such a way that both natural light could pass through it, as well as artificial light. So here you get a kind of cadence during the course of a day, seeing the sun pass over, shadows, clouds, et cetera, and then the transition from the natural light to the artificial light at the end of the day. We also looked at ways that we could kind of gather people in kind of dead-end bleachers. It was a bleacher that went nowhere, partially because this used to be an electrical transformer room here, or not a transformer, just an electrical room, but we knew we had to keep it, so how do we embrace that as part of the project? So on the outside of the building, we wanted to find a way that we could take the relatively, well, frankly, banal geometries of the kind of pre-manufactured building and play it against itself by wrapping a cedar screen around the project. They would then start to peel away or pull back from the existing building, allowing us to thicken and capture exterior spaces. I think I think that they're great possibilities of starting to kind of set up screens and develop thicker skins that I think this building does an exceptionally good job of as well. We also were trying to find a way that this would produce a new entry for the building that would be illuminated at night, and in a sense the screen would actually reach out almost like a hand and encourage you to come into the project. A different shape sometimes these become tongue twisters. So shape section, we should have named them so all of them were easy to pronounce, but somehow, anyways. So this was a project that just opened at Columbia. It's in an existing McKinney and White building, which has fantastic windows, but we were adding a whole bunch of new mechanical systems for this auditorium where the Pulitzer Prizes are given out. So how do we both reconcile all of the new mechanical equipment added in while still retaining views to the windows? And so that really became a kind of question of sculpting the ceiling in a particular way so that it would allow you to have as much visible access to the windows while then accommodating and distributing all the mechanical system and dealing with the acoustics and lighting in a kind of convincing way. So we were working at a kind of modified coffer system built out of a kind of acoustic felt that would then capture and kind of deal with lighting, diffusers, sprinkler systems, and so forth. So we could kind of gain this kind of cohesive ceiling that would then be clearly a new addition into the historic McKinney and White, but kind of be deferential to the windows and to the existing context. The other thing we found with this ceiling is that it actually works very well on Instagram. So of all of our Instagram posts, I think this image has gotten the most likes. And I'm trying to figure out if that's good or bad. So I'm late to Instagram, and I'm still not certain of its efficacy. But anyway, so this apparently is very appealing to the world of Instagram. So, okay. All right, so shear. Shear is a kind of fascinating section that's often used in housing, and particularly what it's effective at is that it allows architects to start to produce difference without losing any square footage, and it operates both horizontally and vertically. Okay, so what do I mean by that? A horizontal shear basically means that the same amount of floor area exists, it's just slid off to the side. It's slid horizontally off. And what this allows you to do is maintain the amount of square footage, but you start to gain differences on the two sides. Mostly what the horizontal shear is used for is for housing projects. It allows you to gain terraces, outside spaces that are part of the project where often you keep a relatively self-similar floor plate. What Henri Sauvage did, which was kind of fascinating, is recognize that even though you get greater access to sun and light on one side, the other side becomes a dark underbelly. And so what he did is put two of these back to back and then place the swimming pool, a program that doesn't need a huge amount of natural light, in that kind of underbelly as a kind of collective program aligned with the kind of more private programs of the apartments. Another variation on the horizontal shear is Big and Plot's mountain housing project. And here you start to realize that the nature of the horizontal shear is completely dependent upon the quantity or the amount of incline. In other words, the more you incline or push the shear, the more terraces you're going to get, but also the more underbelly you're going to get. And what made this work is that the parking garage existed as a program first. In a sense, this is a housing project that's being used to laminate over top of a parking garage. There are many more parking spaces than there are necessary for the housing above it. But here you get an extreme rake, and therefore you get these outside terraces that are almost as large as the apartments inside. Now, one of the other ways to think about the horizontal shear is to start to play it off against itself. So here in Weiss and Manfredi's campus center for Barnard College, they placed the horizontal shear to gather program, but rather than being on the outside of the program, outside of the building, they placed another one on top of it, and therefore captured a series of double height spaces that allow you to stand way into the depth of the building and look all the way through at the various lounges, all the way down to the campus beyond. Okay, so those are examples of horizontal shear, but shear can also work in the vertical axis. And here the interesting thing is that you're basically not losing square footage in your floor plan. All you're doing is starting to offset a floor from one side of the building to the other. Probably one of the best known versions of the kind of vertical shear would be a split level house where you kind of come in halfway up and you have a kind of stair that kind of splits the differences between those sides. What's fascinating about this approach is it allows you to have much greater continuity from floor to floor. It allows you to have more social connections within the heart of the building. And this is certainly something that Hertzberger took advantage of in his school, where the stair that occupies the vertical shear now becomes the gathering point, whereas the more private activities, which wouldn't be necessarily visible from the lines of sight within the central space, are then moved back to either side of the building. Now, a more complex or intensified version of the vertical shear is in Diller Scafidio's Creative Arts Center at Brown University. And here you can see that the vertical shear is set up and then registered by these double line of glass, which keeps acoustic separation from the different programs. But here you get this extreme proximity between disparate activities, whether dance to performance or even the kind of public walking or circulation corridor that then can look down into the auditorium below. It's a kind of interesting way to kind of allow the architecture to induce cross-pollination between different arts programs. And a more kind of prosaic project that we did, we had a client who had accumulated a series of apartments where the floors didn't register, and so we wanted to kind of celebrate that difference, that vertical shear, by placing the stair in that zone and allowing that stair to be a screen that would kind of both veil but also reveal the different natures of the programs within the space. So you would occupy the shear, moving between the split level, but then the nature of this screen would then start to provide a little bit more protection for certain size while putting on display other more public programs within the project. Okay, so hole is the next type of section, and it's as dumb as it sounds. It is a hole in the floor. And the argument here is that you're going to lose a certain amount of square footage, but you gain certain visual connections, you gain certain kind of optical links, you gain certain mechanical system movements. Every building's going to have holes. But in certain cases, architects have really kind of embraced the hole to really change the dynamic of the inside of the space. The key here is that inevitably there's a certain amount of loss, right? there's loss of floor plan area to the hole, and so there has to be a justification on other benefits that the hole provides. So let me go through a couple examples of holes. In some ways, the double height space in, say, an example being Corbusier's Stuttgart housing project, this double height space is effectively a hole that really sets up the hierarchy between the kind of more social program of the living room and the more private programs of the bedroom. But it also allows light to come in. It allows visual connections. It stages the nature of this project. A more grand hole would be, what we would call an atrium, right? And in Frank Lloyd Wright's Larkin building, you realize that the atrium is the heart of the project. This is a project that in some ways is better known for its atrium than for its exterior. It organizes the whole project. It provides the identity. It provides the mechanical system. It is the kind of defining characteristic, and it extends through the entirety of the project. So atriums have been used to great effects, and just to show a couple other examples, the Ford Foundation is a well-known kind of atrium within the center of Manhattan. It's combined with a little bit of horizontal shear, so you can start to see how the kind of introduction of the kind of the green oasis in the heart of the hole would then start to be able to kind of drift up into the building. A kind of fascinating project where there's an attempt to produce a space that was both embedded in the city but clearly independent and different than the city around it. And some of the more spectacular versions of atriums are John Portman's hotels that really take the atrium to a kind of extreme degree. They become kind of spaces of their own right, spaces of spectacle, of vertigo. But even here, there's an interesting use of the horizontal shear to set up the kind of places to dine and eat. And what's interesting is many of these are used to focus back in to the atrium, not to Times Square, which largely the building turned its back on. So it's interesting that in the site of extreme spectacle, when you're in this building, you actually don't often know you're in Times Square. So because the spectacle of the atrium is so overwhelming. Okay. Holes don't have to be singular, and Toyo Ito's Mediatek is a great example of a kind of morselization, a kind of multiple holes spread throughout the project. And what's brilliant about this project is the fact that the hole is actually now mated with the column, right? Two contradictory things in some respects are now fused together through these lattice columns that both hold up the building but also provide connections, provide staircases, provide mechanical systems, provide optical connections between the building. A kind of an ingenious inversion of our assumptions of what a hole does and what a column does. Okay, so in a project for a university for the deaf in Washington, D.C., we were really interested in how you could take the staircase and really expand it, place it into a kind of larger opening within the building in order to engender better communication. Most of the communication is done through sign language. Sight lines are crucial, and so the thought here was that the stair wouldn't simply fit efficiently within its zone within the floor plate, but it actually exists within a much greater atrium, much larger atrium, so you could have these connective tissues or connective links from floor to floor and maintain conversations when you're on the stairs, moving off the stairs throughout the building. And on the ground floor, we are looking at ways through a kind of staging or kind of terracing of the lounge where you could have smaller gathering points for conversation, but then turn it into an auditorium, a kind of gathering space for everyone, again with sight lines for sign language. Okay. We had the opportunity to work on a museum in Austin, Texas that's gone through 2 stages. It was an kind of fascinating building. It's right in the heart of Texas, in Austin, Texas, I should say. Congress Avenue is here. This is 7th. And it used to be a theater in the 1920s, a proscenium theater. It was turned into a department store in the 1950s, where they basically put in a second floor. In a sense, we had a kind of Russian doll of structure. We had an exterior steel structure from the theater, and then placed inside of it was a metal structure for the second floor of the department store. And a lot of our work took place as a kind of series of tactical modifications of the building, with a key component really being getting people up to that main second level. So introducing holes or kind of stairs that would then link between these two different levels. And in particular, we were interested in a stair that would be simultaneously heavy and light. The bottom 3 treads would be cast concrete that would form a kind of bench or seat, a kind of weighted gravity-based component, whereas the other 21 treads would actually be suspended down from the roof deck, kind of floating, lightweight, very large, but still almost kind of ephemeral in comparison to the concrete. And that these would really literally extend down from a skylight connecting to the roof deck above with the same material used on the stair treads as on the roof deck. And one of the things that we liked very much is that the openings within the floors would just be squares, but because the treads were all inclined to match the geometry of the slope of the nosing of the stair, you would get this transformation of geometry at the base of the stair working its way up. In other words, at the base of the stair, it would be 5 feet wide, but as you worked your way up, it became 8 feet wide. So in a sense, the stair would open up to the main gallery as you worked your way up into the building. We've been working with ways to get other things through the building through different types of holes. Not the least of which is trying to figure out how to get crates through this existing building without building a very, very large freight elevator. So our approach was to work with a kind of scissor lift that could lift the crates up into position, and then also then disappear back down into the floor, so that we lost no square footage of the gallery to this utility, but still allowed for the movement of very, very large crates up to the upper level. The roof deck has proven to be one of the kind of best aspects, the most used aspects of the program, used for screening, gathering, but it's in the heat of Austin's sun. And when the building formed a kind of new identity, it merged, Art House merged with the Austin Museum of Art and became the Contemporary. We were asked to come back and kind of rethink how we would, in a sense, solve some of the weather problems on this roof deck. And this allowed us really to kind of introduce the possibility of a kind of a stacked section or a kind of floating plane, but one that would be high enough that it would appear that it was almost kind of not necessarily producing an interior, but a kind of space that was both inside and outside, with a kind of knife edge that would give it the appearance of being extremely light. Some of you may recognize the sign, which is the artist Jim Hodges' work with Liberty and Justice for All, which used to be in front of this building. And one of the nice things about this canopy is it became a kind of backdrop for the installation of Jim Hodges' work, which forms a kind of that transforms during the day, and also is a kind of great backdrop for events that take place on Congress Avenue, a major kind of protest and parade site within Austin, Texas. In order to provide some mitigation against different weather possibilities, we also work with very, very large curtains that could be retracted and kind of simply pulled around, making the space into a kind of quasi-interior. But it really does allow us to change this very, very high space into a kind of ephemeral, almost kind of glowing box, while at the same time also then revealing it back to the city and opening up and connecting this space to the heart of Austin. And it's become a very kind of popular place. It works really well, and I think it's because it doesn't feel either interior or exterior. It really feels as though you're part of the city, and the stainless steel mirror on the back of Jim Hodges' letters do an amazing job of kind of adding to that kind of dynamic of exchange between the activity in the building and the life in the city. Okay, so incline is a way of moving through section by kind of oozing plan from one floor level to another. It can be thought of as ramps, it can be thought in different ways, but it's producing continuity from one level up to another level. Now, what's fascinating about that continuity is it comes with a problem. In other words, you might get, say, 4 feet of continuity up Corbusier's main ramp, but you get about 33 feet of discontinuity in the other direction, right? So it provides a limited amount of continuity, but it comes with a lot of discontinuity. It comes with kind of impediments that the ramp produces in the continuity of the plan otherwise. And that really is the defining characteristic for the incline. Now, what Frank Lloyd Wright and the Guggenheim did is say, okay, I'm going to get rid of that problem by making the entire building into the ramp, so that we get continuity as the defining characteristic. And where we might have had discontinuity from side to side, he's going to place a very large atrium, large hole in the middle. So in a sense, getting rid of the problems of the ramp, the discontinuity problems of the ramp. Rem Koolhaas and OMA took a totally other approach. They basically said that the discontinuity is actually what they're going to celebrate, and the entire nature of this project is about intensifying the friction along the line between, say, an auditorium sloping down and a circulation staircase going up, versus a walk moving through the heart of the building that allows you to kind of, in a sense, enter the building, but without actually going to its interior. The entire project is about the discontinuity made possible through the ramp. So we've done some projects with continuous surfaces. This was a project that looked at what would happen if you were able to get rid of the toxic emissions from automobiles. Could electric cars allow us to have parking have a much greater proximity to program? In other words, without the kind of toxic fumes, could you actually change the very relationship between parking and different interior programs through a drive-up skyscraper? Could you take the suburban desire of parking with proximity to program and play it out in an urban footprint? So this is really a kind of 70-story tower. It's a drive-up skyscraper that then choreographs retail on the lower level, has a hotel in the kind of middle floor. There's always an intertwining of a parking program as well as an interior program, as well as a kind of an express ramp that would navigate up through the building much more quickly. And then at the upper levels would be a commercial office area and then residential at the top. So in the retail level, we imagine this is really a strip mall that's been wrapped around itself. Every parking space is a good parking space, and more importantly, the means of getting from your parking to the program doesn't go across a windswept kind of empty parking lot, but actually goes through a kind of an atrium, a more socially interesting, more dynamic space connecting parking to the strip mall. Similarly, on the motel or the hotel level, we imagine this as being a kind of motel wrapped around a kind of spectacle atrium, so that you would park above your hotel room, but the cumulative effect would produce this grand kind of lobby, and then even some details where you could actually dive off of the parking garage into the swimming pool. Just ways of thinking about kind of the pleasures that may be made possible by rethinking the positions of parking garages. And even in the residential area, being able to park on top of your apartment while still maintaining this kind of vertical kind of utopia extending throughout the building. Okay. So Nest is the last distinct model of section, and it's characterized by section diagrams that work with a volume of space as opposed to a flat slab. Most of the other section types that I've been talking about are based on thinking about the key component of the building being a floor plate. This really says what happens when you start thinking about the component of the building as being a kind of volume. And how do they nest either into each other or intersect each other in different ways, and what are the consequences in section from doing so? So a good example, a kind of diagram of a nested section would be Fujimoto's house, where you have one volume identifying the more kind of intimate domestic spaces. You have another volume marking the exterior envelope of the building, and you have yet a third diagram or volume identifying a kind of property boundary. Each of these are perforated by self-similar apertures on both walls and ceilings, and you get this kind of interesting exchange between these different nested volumes. Often what you get with nested volumes are links between the different kind of enclosures that both kind of foreground what happens within the individual box, but also how it then relates to the subsequent box. A good example on a much smaller scale is Charles Moore's house. It's very, very simple 2-by framed house, but he's managed by kind of capturing skylights within the wood joists, kind of gathering light into two kind of privileged parts within the building, within the house, a swimming pool and a dining area that then start to kind of give this house a kind of sense of scale and celebration that it, or really performance than it wouldn't otherwise have. Herzog and Miron's Prada building in Tokyo starts to embed kind of more private functions, changing rooms within these kind of tubes that are actually used structurally to link to the diagrid skin of the building, and they are then embedded into the floor plates, the stacked floor plates of the building. So again, a fascinating way in which structure is thickened to become a nested volume that allows different activities within the overall volume of the project. And the Beinecke Library at Yale is a good example of a nested section that has thermal performance. In other words, here the rare books are really in a kind of vitrine, a stacked vitrine, with their separate kind of mechanical requirements to preserve and maintain the books that are then caught within the translucent stone volume. Now, what's fascinating about this building is people tend to associate the building only with these kind of two nested volumes of above, but you start to realize the amount of program, the stack program below necessary to enable this kind of more privileged kind of nested figures to exist on the campus. And one of my favorite nested sections is purely done for thermal performance, right? Here you have, in a training center, you have two fairly banal, actually quite cheap buildings that are placed within a completely passive performing glass and timber volume that's able to start to produce a kind of an interstitial weather condition inside. So if it's, say, 30 degrees or freezing outside, it might be 50 degrees in here purely from passive performance, and then that means the amount you have to heat to get it to, say, comfort level in here would be substantially less. But more importantly, you get this interstitial space that, even though it's in Germany, it feels as though you're in the Riviera. It's palm trees, very strange kind of interior produced by the nested section. With a residence hall in Ohio, we were looking at ways that we could start to kind of position different volumes for certain social benefits. Here we looked at a way in which each of the hallways would have a kind of cantilever volume, really like a theater box, so that you could be inside the building witnessing the comings and going into the building itself. And from the inside, these would both be kind of reading nooks or kind of gathering places, but when you're in here, you're able to look back down through the kind of larger glass or channel glass enclosed exterior courtyard and see activity taking place, as well as look across to the other hallways through these kind of the reciprocity of these nested volumes. Okay. So this is the project that we're super excited about in Telluride for the transfer warehouse. For those of you who know Telluride, it exists as this one of the oldest buildings in town from 1920s. The stone walls are still in place. It's had fairly utilitarian purposes over the years, but it still exists, right? And more importantly, it's lost its roof. it really is a kind of wall that has an interior that's outside. So this is a project that's just screaming out to have a nested section diagram, right? It's like, you know, so when we did this competition, we knew that we were going to work through the nested section. One of the volumes was already given, so how do we think through the relationship of that existing enclosure, capitalizing on the fact that it's already being used in really interesting ways to make a space that would really celebrate this unique characteristic. So early sketches looking at kind of ways to kind of place a volume within this space. And what this allows us to do is also deal with some of the humidity problems presented by the very porous historic stone walls without having to clad the inside of those walls with drywall and therefore not let them be part of the nature of the project. So in a sense, we said, let's actually place the new volume back from the historic walls. This is an area that would set up this interstitial gap, but more importantly, it would allow us to both control temperature and humidity on the inside while not necessarily worrying about humidity as much in the more social spaces that surround that area. And that diagram then really informed the material nature of the project. We would work with the stone walls, placing them on a new concrete foundation, but then very importantly, placing a kind of timber figure made with cross-laminated timber structure on the inside really as a kind of discrete volume, and then kind of the play between the timber and stone would be kind of registered and made possible through this glass interstitial connection. So from the outside, in effect, the building is very discrete. It's not that visible, and that's fine. We wanted the kind of the historic walls to be the kind of dominant visual public presence, and it's really when you pass into this courtyard, the kind of inside-outside courtyard, you start to see the building and how it responds to the existing walls. It pulls back, it opens up in different ways. We're working on ways that we can have retractable skylights as well as enclosures to provide kind of all-weather use of the space, and then also looking at kind of shades for nighttime use, dark sky initiative restrictions. The heart of the project really is this exchange between this new volume and the old volume. So even the building is in a sense carved away to reveal views internal to itself, views out back to the stone wall, and looking at the kind of reciprocity in a variety of different ways. Even looking at kind of registering that gap with a staircase that would move between the main gallery on the second level, but also work its way down to a kind of screening room or a performance space in the lower level. But again, the figure of the stone, of the wood, the legibility of the wood figure is still clear within the basement. The stair, we wanted to find a way that it would change as it worked its way up. It was poured concrete on the lower level. It would then turn into a kind of metal stair. And then as it works its way up, it would actually become a kind of wood carved volume, all illuminated by the skylights up above. So here you see the stair kind of working its way up around the project. The main gallery space is on the second level, accessible by this stair as well as the elevator. And this, one of the interesting things is that we had imagined that this would be largely a white wall gallery. And I think we've gotten some kind of interest in not having as a conventional white wall gallery, but something that would open up even more. So we're excited by that possibility. Because one of the things that we're trying to do is to find a way that the building would kind of look at itself through these apertures, through these framing devices, and then even from the street looking back, that there'd be a slight misregistration between the old and the new that would kind of look at interesting moments of parallax as you would walk down the sidewalk. And even in the elevator, we kind of set a glass kind of window so that the space between the two would be then visible within the elevator itself. So as you work your way up the stairs, I mentioned it would carve into the thickness of the wood volume and then leading up to the rooftop out to the amazing views of the box canyon of Telluride around, both in night and day. In order to kind of emphasize the role of the nested section, we even kind of built the model to be a kind of nested kind of box, so that when we would ship the architectural diagram would be legible even before we opened up the project. So. Okay, so very quickly, hybrids. Those are really the kind of distinct models we think that are used quite a bit. But as I said in the beginning, it's through hybridization, through different ways of kind of deploying these section types that most architects and most interesting buildings are realized. And so just to give a couple examples, Sana's Rolex kind of learning center, this kind of amazing building, can actually be seen as an extruded stacked section that's been shaped and then perforated by a series of holes. Similarly, you can look at Kengo Kuma's tourist center in Tokyo as really being a series of stacked shaped sections, which itself produces certain problems, and that's what Kengo Kuma has spent a lot of time trying to figure out. How do you deal with that interstitial space between these two, between one shape and the shape above it. Herzog and de Meuron's Vitra building is really a kind of shaped, stacked, nested section that's rotated around to produce an atrium. And even the Seattle Art Museum is really this kind of excess of sections, stack, nest, incline, and so forth. So one of the intents of the book is to provide a kind of point of departure to then start to understand how these things get combined in different ways. So, and very quickly, a project where we did, while we were working on this book, we realized we wanted to do every section type possible. It became a kind of excess of section. It was a student center. We opened up the classrooms, made a commons area, and then working with inclines, shears, horizontal and vertical shears, kind of stacked sections, holes, et cetera, produced this kind of excess of section within the kind of heart of the campus center. And here are a couple of views of it from the inside, as well as from the outside, the kind of relatively more normative side of the building, and then as the building opens up to the campus beyond, the more unusual deformation of the roof as it kind of mates around and kind of encoats that section area. Okay, so one question we always get is, how do we do these drawings, particularly when we talk to architecture schools? So I wanted to give a little bit of a sense of how we went about this. And really, as I said in the beginning, one of the hopes was to turn this into a kind of a visual scholarship. To do this, we would not only kind of look at photographs and try to understand how the building existed when it first opened. As much as possible, we would try to go to the original working drawings. Every single one of the buildings in the book has been built, so we knew that there were working drawings somewhere. This is Buckminster Fuller's partner, who showed us some of the working drawings of the Montreal Expo. We would then build 3D Rhino models of the entire project, then spend a long time trying to figure out where to cut it, where to set the horizon line to get the proper view. What's interesting here is we didn't cut through the middle, but we actually cut just a little bit in front so that it allowed you to see more of the volume of the geodesic dome. We would model as much as possible both the interior context when it opened, as well as the exterior to the best we could. We always felt that we were wrong because we could never get enough information to fully know. So these were, in a sense, based on the available material, as close as we could get to a degree of precision. Went through a lot of redlining, which is very odd to redline other people's work, but to try to get to a degree of precision about the projects. There's a whole host of people who worked on this in our office. We did not use unpaid labor to do this. This was all people who were paid in our office, mostly staff who, when they would have some time between projects, they'd come on board. But it was more of a labor of love than a business proposition. And we've been experimenting with the possibility of a coloring book coming out of this. So these are some early guinea pigs, our children. So we have Henri Sauvage's Blue Period, which is quite elegant. I'm particularly fond of this one, which is my daughter's psychedelic version of Herzog and Meuron. And then, the idea of influencing young generations to think about section not as something that gets cut after the design has occurred, but actually is generative of the design, I think is one of our goals. So there is now a coloring book that we have available, and it's been a kind of pleasure both to work on this, but also to see the way in which the book has had some degree of influence and has provided an opportunity for thinking about architecture in a very different way, different than simply plans and exterior image. So I thank you very much for coming. It's been a pleasure being here.
So I know we've gone a little over, but if anyone would like to ask any questions, we can take, if Paul doesn't mind, maybe 5 or 10 for questions.
You represent Paul Rudolph drawing in your...
In the lecture, there are 2 Paul Rudolph projects in the book. Yeah. So yeah, one of the best-known sections in the 20th century is his Art and Architecture building at Yale, which has something like 750 individual levels if you count every step as a unique level. And we did include that in the book. What was fascinating is the drawing he did of the section perspective, which is one of the canonical section perspective drawings, we're convinced is actually drawn with a distorted depth. It's actually drawn manually to increase the amount of depth in the plan. So, because when we modeled in Rhino, we could not, no matter what lens we tried, we could not get the illusion of depth that he did in his manual drawing. So, so I'd like to say he cheated, but I think it's actually more he celebrated section through a kind of logical deformation. But yeah, no, there's no question that Rudolph was a kind of key figure in thinking about these projects. So, yeah.
It's for them.
Okay. Did you consider Guastavino tile, like vaulting systems at all while you're considering this project?
Yeah. No, it's a great question, and certainly, you know, the Guastavino tiles and the vaulting, the use of, you know, the thin-shelled projects project that I showed is a good example of where the structural shape and the kind of geometry are perfectly aligned, right? And the shape section is very much part of that. One of the things that we set as a limit, though, is we actually said that all of our analysis was going to be post the concrete kind of slab and the steel frame. So most of these buildings are from 1920, 1930s on, in part because we realized that there's such a wealth of alignment between structure and shape and section, particularly, you know, Gothic cathedral, et cetera. You know, in part, the problem that we now have in section is that section's not efficient, right? Because our building types don't necessarily require it. Where some of the fascinating things about the pre-20th century construction is that in order to get those kind of longer spans, you would have to have that alignment, right? So a lot of this work is really trying to figure out, all right, how do architects justify the role of section when it isn't necessarily needed? So when there's a kind of demand on the relentless repetition, which kind of capital tends to want, right? So, but it's a really good question. So. Well,
Great.
thank you
Thank you,
very
Paul.
much. Thank you. So.
Yeah.